All right, so today's lesson objective is using the activity series to determine or to predict if a chemical reaction will take place. Now, the essential question which you should be able to answer is how do you use the activity series to determine if a chemical reaction will take place? That's all we're going to do. How do you apply the activity series? Now, let's look at a very small, short background. Now, the picture in front of you is a silver cup. It's that of a silver cup. It looks so ugly, but once it's polished and everything, it looks very beautiful. But as it is right now, this cup is undergoing a chemical reaction. Now, the silver, which is an element, a metal, is reacting with this hydrogen sulfur in the atmosphere. So in this case, the silver will react with the hydrogen sulfide to replace the hydrogen in the hydrogen sulfide gas. So at the end of the day, you're going to have a single replacement whereby silver replaces hydrogen in hydrogen sulfide. Now let me write the equation. Let me do the equation on the board on the screen so that you see what I'm talking about. So here I have silver, so that's the symbol for silver, plus hydrogen sulfide, which is a gas. Now in the presence of moisture, it becomes aqueous. So what happens is that this silver will react with this and replace hydrogen in this compound. So this is a compound and this is an element. Okay, remember, an element and a compound, when they combine to react together, gives a single replacement reaction. So in this case, you're going to have Ag, two of them, and sulfur plus hydrogen gas. So that's what's going on here. So this is the silver sulfide. That is the ugly part of that cup that you see. Okay, so that's this part. Those are the black dark spots that you see in that cup, which is the silver sulfide. Okay, so now this is a single replacement reaction because the silver, which is in this case this guy here, is replacing the hydrogen in this compound to give you hydrogen sulfide. So that's why it's called a single replacement reaction, because one element replaces another element in a given compound. Okay, now you can fill this one out later on before you move on. Now this is the activity series. In the activity series, you have series of elements arranged in order of their reactivity. So what we're saying here in this activity series of metals is that the metals on top are more reactive than the metals at the bottom. So as you're going from top to bottom, the reactivity decreases. Now, example here is that of magnesium and copper nitrate. Magnesium is up here. It's more reactive than copper because magnesium is on top and copper is at the bottom. So in this case, magnesium will replace copper to give you magnesium nitrate and copper element. Now, if you look at this second example here, Au, which is gold, is way at the bottom, is lower in the activity series than hydrogen, which is up here. Because gold is at the bottom, gold cannot replace hydrogen on top. So that is why you have no reaction here because gold cannot displace hydrogen. Hydrogen is not a metal. It is placed in the activity series of metal because hydrogen behaves like a metal. So that's why it's part of that activity series. Now, if you look at this second half of the activity series for non-metals, you could see the same thing. The non-metals, in this case, most of them are halogens, are arranged in order of decreasing reactivity. So fluorine is more reactive than all the other non-metals at the bottom. That is why in this reaction, this example, when you react fluorine with sodium bromide, fluorine will replace bromine in this compound to give you sodium fluoride and bromine gas. Now, that is basically how you use the activity series to predict if a reaction will occur. Now, let's do one example. You can look at this, watch this video later on your own time. Now, let's look at these questions here. You are supposed to practice with this. Let's do the first one together. It says drop the words into the correct boxes. We're going to use this to complete this this reaction. So here it says zinc plus copper sulfate. With this, the first thing you have to ask yourself is, will this reaction occur? So here we're going to look at zinc and copper. So zinc is up here and copper is at the bottom. So you can see that zinc is higher in the activity series than copper. Therefore, zinc can replace copper. And in that case, zinc, it now becomes zinc sulfate plus copper. So I'm going to move this zinc sulfate here, and then copper plus copper. So that will be the product of that reaction. So you're going to look at each of this reaction and determine, based on the activity series, you're going to determine if the reaction will occur. If there's no reaction, for example, copper is lower than zinc. So this is going to be no reaction because copper cannot replace zinc in that compound. So therefore you say that one is no reaction. So you can say all these ones here are metals being reacted with a compound. And in the next one that you do also, this one has to do with non-metals. Here you're going to complete this equation based on the fact, based on the position of the element in the activity series. If you remember, if it's above it, you can replace the one beneath it. So in this case, the first example is here. You have chlorine reacting with sodium bromide. Now you're going to compare chlorine with bromide ion. Chlorine is up here, is above bromide atom. Therefore, chlorine can replace bromide in this compound to give you sodium chloride and bromine. So it's going to have sodium chloride and bromine as your answer right there. So once you understand how to use the activity series, you're able to use that one to begin to predict and complete the given reaction. Does that make sense? Carol,
Yes.
okay? Trevor, no question?
No, not right now.
Not right now? Okay. So I'm going to let you guys finish the rest. You can look at the video that you have there. And then if you have questions, just shout it out to me. I will